Okay, another question here from Waleed. Thank you so much, buddy. So, section 4.5, practice question 11. What's the situation here? Well, you've got a spring shooter. So what it is a little barrel here, a spring, and an object that's going to be shot out of it. And what happens is we compress this spring by 0.04 meters. The spring constant of the spring we're being compressing here is 12 newtons per meter. And the mass of the object that is going to be shot by the compressed spring, 8.3 times 10 to the negative 3 kilograms. It's shot out. It's actually shot out horizontally. Shot out horizontally. And it flies through its parabolic motion, traveling a certain amount of x displacement, which we do not know at this point. But we do know that the bench that it shot from was 93 meters above the floor. So therefore, as it goes through its parabola here, we know that it's going to have a change in y position, therefore delta y of negative 0.93 meters. So there's actually two parts to this question to solve it properly. The part one part right here is strictly on the bench. And it's solved by using the law of conservation of energy, that the total energy initial is equal to the total energy final. Now, the total energy initial is all elastic potential energy. The spring is compressed by a certain amount x. The object's not moving when the spring is compressed. It's about to be shot out, but it's not moving yet. So there's no kinetic energy. And the entire motion happens on the bench. So it'll never change height. Gravitational potential energy is not part of this. What is going to happen? Well, at the end of this, while it's still on the bench, just about to leave the bench, it's now going to be moving as it's just about to leave the bench. So all of that all of that elastic potential energy has been turned into kinetic energy. So we can write out the expression for elastic potential energy. We can write out the expression for kinetic energy. As I take a look at the expression here, I notice there's a half on each side. They cancel out. And I'm left with kx squared is equal to mv squared. I do some algebra, some rearranging, and I get the speed squared as it's just leaving the bench is equal to the spring constant divided by the mass of the object multiplied by how much the spring was compressed squared. I have to find the square root, and I get the speed as it leaves the bench, 1.5 meters per second. Now I'm going to take this 1.5 meters per second, it's a speed, look at the diagram and introduce it into part two of the problem, which is actually a projectile motion question. All right. So that 1.5 meters per second speed turns into velocity initial x for the projectile motion, which is plus 1.5 meters per second, x hat. And since it's being shot out horizontally, the initial y velocity is 0. So this is the linking between part one and part two. The speed of part one becomes the initial velocity of part two. I'm then going to use this equation right here because I know the y displacement. I know initial velocity y is 0. I know I'm on the planet Earth. This is negative 9.8 meters per second squared. Initial velocity y is 0. This whole term is gone. Bingo, bango. All right. So what do I have left? I have left delta t squared, and I'm going to do some algebra here. I'm going to multiply each side by 2, so that half is gone, and I'm going to divide each side by the acceleration, so it cancels out here, and I'm left with the time squared is equal to 2 times the displacement divided by the acceleration due to gravity, and then I have to square root that, and all of a sudden I now have a calculation that tells me how much time is this in the air for. And like many projectile motion questions, time is the link between y and x. So I use this equation here. The x component of the displacement equals how fast it's moving in the x direction multiplied by how much time it was moving in the x direction for. Well, if you remember in projectile motion, x velocity never changes. So look, I know this. It's 1.5 meters per second. How about the time? Do I know how much time it was in the air for? I do. Right here, I just did the calculation, whatever it may be. I multiply the two, and I get how far it has traveled in the x direction. I hope this helped. Keep asking questions. Please, please, please. Thank you.